Hello and welcome to Azure Spring Clean 2024. My name is Mark Tinderholt and my talk is Commit to Control, a GitOps tale of policy as code. As I mentioned, my name is Mark Tinderholt. I work for Microsoft on Microsoft Engineering within Microsoft Azure. I just wanted to call this out. These are my opinions. I do not speak in any official way on behalf of Microsoft. I happen to be very passionate about the Azure platform and teaching others about it, especially in the automation and infrastructure as code space. So today we're going to be talking about policy as code. In my work, I do a lot of infrastructure as code, but I think it's really important, especially as we think about Azure Spring Cleaning. It's a great way to take the practices that we employ with infrastructure as code and apply them to the policies that we apply to our environments. To really understand that, we kind of have to first understand what we mean by policy as code. And so with infrastructure as code, we started off, trying to basically provision things to the cloud way back in the day, right? We provision things to the cloud using our mouse and keyboard and a fancy little portal or console or whatever you happen to be using, and you clickety click, and you provision things out to the cloud. And this is not so different than how we apply policy today. There are ways of applying policy through the different cloud platforms, and you clickety click those policies into production or into your environments wherever they may be. But just like with infrastructure, we have some opportunities to be gained by codifying that. First of all, once we codify that, we can wrap that code with software development processes, which gives us a whole slew of benefits, such as a pull request process, where we can have reviewers that have the authority to review and approve those changes to our code. To look at the code before it actually makes it to the target environment. With Git, we have an audit trail of all the changes that were made, that were shepherded from the minds of our developers into the target environments. And so by implementing these software development processes around infrastructure as code, we gained a lot of benefits in managing our infrastructure out in the cloud. The same benefits can be gained when we apply it to policy as code. And that's what we're going to be talking about today. So rather than defining and codifying your infrastructure and what is deployed, we're going to be defining how it can be deployed, how your infrastructure, how your cloud resources are allowed to be deployed. And so this pivots like what we're codifying from the actual things to the controls that we place on our environments. And so when we do this, we get the benefits of the same things that we got from infrastructure as code. We get the pull request process. Of course, these are going to be different people reviewing the pull requests. They're going to be enterprise architect folks. They're going to be enterprise governance folks that define these policies and review these policies, and the scope of those policies, right, in terms of where they're assigned across the organization. Is this a policy that we're just testing out? Then we are okay with it being very narrowly assigned. If this is something that we've rigorously tested, we can broadcast this across to the masses. Likewise, when we use policy as code, we get point-in-time access to, how did this actually get approved? Like, how did we provision this thing? What was the policy at that point in time? We can see what the controls are on our environment over time using this Git history. So just like infrastructure as code benefited from this codification of what people were doing manually, policy as code can benefit from that as well. So really, applying policy as code and committing to control is about organizing your policies and applying a GitOps model around that. But in order to do that, we kind of have to understand what GitOps is. And so let's think about that. What is GitOps? GitOps, is one of those words that, means a lot of things to a lot of people. However, really, it's just about taking Git, which is a technology for source control management, and using it as a foundation for an operating model. And so for application and infrastructure as code, that has really manifested itself as taking our application code and adding infrastructure as code and the configuration of our application to create an end-to-end solution that we manage through source code, and create packaged versioned artifacts that describe our environment that we then publish out to whatever environments we're targeting. And so when you apply GitOps to your applications and to your services and to your solutions, right, there's going to be application code, there's going to be infrastructure as code, there's going to be OS configuration potentially, whether that's containers or VMs, or there's going to be platform configuration, if you happen to be targeting a serverless platform as well. So really, it's just applying these software development processes via Git flow, and there's various ways that you can set up Git flow and operate Git flow to manage, these code artifacts that ultimately translate into your production and test deployments. But really, it's about managing this stuff using software development processes. Now, GitOps really has two main approaches. One, which has been around for quite a while, it's kind of the push model, which uses CI/CD, continuous integration, continuous deployment, or continuous delivery, whatever, pick your poison there. And really, this is where we have pipelines that have, a task-based process sequentially. Sometimes, some parallelism is involved there as well. But essentially, we have a number of steps that we want to execute in a pipeline, and they're going to go reach out and touch the environment. That's the push model for GitOps. Now, there is a newer model that has become a bit avant-garde because of the Kubernetes space, and that's the pull model. And that's using a CD-hosted agent that basically runs inside of the target environment, usually Kubernetes, that instead of reaching out and touching the environment, it lives in the environment, and it goes and pulls your deployment artifacts from the repository that they reside within and deploys them out into the environment that it lives in. So that's kind of that pull approach. Now, GitOps tends to be often, in people's minds, synonymous with this pull approach, but really, we've already established GitOps is just applying, a Git flow process to our operating model. And there are two different ways, and probably more, but there's two main categories of ways of doing this. That's the push using CI/CD, and then the pull using typically a Kubernetes CD hosted agent. But oftentimes that pull approach has certain team structures that are needed in order for that to work, right? Because in order for that pull, that CD hosted agent to be there, well, somebody has had to have already provisioned that Kubernetes cluster and set up that CD hosted agent. And this is where the establishment of a platform team that manages like a bunch of party clusters for Kubernetes is already out there and operating. And then you've got app dev teams that really don't have to manage those party clusters. They really just have to manage their application code and their CI process. And then the CD process is handled by them dropping those Kubernetes YAML manifests into source code, which then that CD hosted agent goes and pulls and deploys out of the Kubernetes cluster. So that pull approach kind of implies a certain team structure and split between the roles and responsibilities, which is commonplace now between the app dev team and the platform team. So as you can see, enabling GitOps can be done in more ways than one. We have, of course, our application and our infrastructure code, but it can also be employed in managing our policy. So how do we do that? That's where Azure Policy comes into play. So Azure Policy is one of Azure's superpowers. It's a technology that allows you to control what Azure resources get provisioned, how they get provisioned, where they get provisioned, and all the things. And it's a really impressive service that you're probably already using today, but we're going to show you how to do that using Terraform to implement these policies as code in your code bases. But in order to do that, we kind of have to understand how Azure Policy works. So everything in Azure gets deployed through the ARM control plane, right? Which is this REST API that all of these requests come in to provision resources, to change resources, to delete resources. They all come in through the ARM control plane. And these requests can come in from a myriad of different client tools. We've got the Azure CLI, we've got the Azure portal. I mean, that's where most people spend their time, right? You have the Azure portal. The Azure portal is essentially a client for the ARM control plane. And then you have other infrastructure as code tools like Terraform, Bicep, Pulumi, whatever, that are ultimately hitting that ARM control plane, hitting the REST API, and submitting their deployments either as ARM templates or as individual REST API calls to the control plane itself. Now, this is where Azure Policy sits, and it's kind of sneaky. It's always there, sitting there, but it has to be activated. It has to be enabled within a particular scope. And that scope can be, at any level of the Azure topology. More on that later. But really, the way Azure works is with these resource providers that are essentially big buckets of different resources that can be provisioned. Every resource in Azure has its own schema, has its own parameters that can be passed in to configure the various features and capabilities of that particular service. And so this creates a tremendous amount of complexity in terms of what are the approved ways of provisioning all of these things. But resource providers provide an organizational structure, a uniform organizational structure for all of these resources. So the resource provider is the type, and it implements the specific capabilities of that class of service. So virtual machines would fall under Microsoft.compute. Virtual networking falls under Microsoft.network. Cosmos DB falls under Microsoft.documentDB. That is a category. Within that category, there's a tremendous amount of different biodiversity, different flora and fauna that exist within that category. And each of those resources within that category do different things, and as a result, have their own schema. And so Azure ARM, the control plane, delegates the responsibility of all of this diversity and biodiversity of all these different Azure resources to these individual resource providers so that they, can know all of the things about their resources. Otherwise, ARM would be this huge monolithic thing. So in delegating that responsibility across these resource providers, ARM allows each resource provider to kind of maintain its own little walled garden and maintain its own rules and validations and things like that. But ARM requires each of these resource providers to have a uniform way of interacting with the ARM control plane, right? So there's a resource type, there's a properties block, there's an Azure topology that defines the scope in which these resources are provisioned. This uniform interface between the ARM control plane and the resource provider enables something like Azure Policy to operate in a uniform way across all of these resources. And basically, Azure Policy becomes this arbiter of what's allowed versus what's not allowed. And it doesn't have to know all of the implementation details of each resource provider. It just needs to know what values are allowed at what paths within each resource's specific schema. So you can define Azure Policy in a uniform and consistent way across all Azure resource providers, across all Azure resources, as long as you know the resource type, the resource path, and the values that you want to allow or not allow, right? So this allows you to handle, having radically different configurations for an Azure virtual machine, for example, versus an Azure virtual network versus a Cosmos DB. And this is critical to enabling policy at scale to be applied across large enterprises and small. So we have the Azure ARM control plane basically as the front door of Azure. We have all these clients that users are using to send in these requests. And we have resource providers that are ultimately the final stop where these things actually get provisioned. But Azure Policy sits in the middle and processes these rules that are scoped to different points in the Azure topology and decides whether or not something's allowed or not. And that mode that is set on the Azure Policy can be set to either enforce or audit. And enforce is basically, if your incoming specification for across whatever resource providers you're trying to hit, if it does not meet the policy, talk to the hand. It's not even going to make it to the resource provider. We are going to reject your request based on its non-compliance with our policy. Inversely, Azure Policy can be set in audit mode, which rather than taking a very proactive, block, deny action, Azure Policy is simply, it's being Santa Claus. It's saying, okay, I'm keeping a list, I'm checking it twice, and I'm going to, write down who's naughty and who's nice. And so when you submit resources through the Azure control plane with policies applied in audit mode, those resources are going to go through just fine, no matter how you've configured them. However, there's going to be a little green check. There's going to be a little green check or a little red X that says you're good or you're bad. And basically this allows organizations who, maybe are testing out new controls before they want to apply them so that they don't hamper the development process of all of their teams across the organization. They can sort of collect, a laundry list of technical debt, right? And they can let the teams go do these things, but then later on, fix these things up so that the red X's turn into green checks, right? So this is a more lenient and a more benevolent way of applying Azure Policy that allows your teams to keep doing what they're doing, but allows you to know, okay, these things are done this way, but they're not ideal, right? And this allows organizations to balance kind of business priority versus, non-functional requirements, right? So if you really need to get it out the door, you're enabled to do so, but there is somebody keeping track of things so that you can go back and fix things up later. So it's important to recognize those two different modes for Azure Policy. And we'll talk more about how those modes manifest themselves into different effects later on. But so what is a policy? What does a policy look like, really? We understand now. We understand now where Azure Policy sits in the Azure landscape. But what does an actual policy look like? Well, really, a policy is scoped to one of the points within Azure's topology. So you have tenant, management group, subscription, resource group, and all the way down to an individual resource, although this is rarely actually applied. But these are all potential scopes that a policy can be applied. A policy itself is called a policy definition. And these policy definitions can be grouped into policy set definitions, but in the UI, they're often called initiatives. So you can use policy set definition or initiative interchangeably. Likewise, a policy and a policy definition are used interchangeably. But the policy definition is essentially where the rules live, and then a policy set definition is when we group these together so that we can, apply them a little bit more conveniently at scale. So these are the two devices, the initiative and the policy, that we can use to define what's allowed, what controls we want to place onto our environment. But then we need to actually assign those rules to the target scope. So we need to create policy assignments. And a policy assignment is really simple. It just points at the policy initiative or an individual policy, and it points at a target scope. And that linkage creates that rule to activate Azure Policy whenever any deployment, whether it's done through Terraform or Bicep or the Azure portal or the Azure CLI or PowerShell or whatever, any deployment, however it makes its way into Azure and hits the Azure control plane, now that assignment is there at that particular scope, if any deployment happens within that scope, Azure Policy is now activated and will apply and will analyze the rules that are assigned to that particular scope. So now let's go look at what an individual policy definition looks like. And policy definitions have three main parts. There is, of course, metadata, which is mainly for humans, right? It's for humans to understand what this thing is and what it's all about, what version it is, so that we can maybe select, different versions and to have a better understanding of like what is going on, what is the intent of applying this particular policy. The next is parameters, and these are inputs that can drive change within the actual policy rules themselves. And so you can see here we have kind of a JSON schema going on where we set these values. And with parameters, you have it's similar to an ARM template. You have different types. You have metadata that describe the parameters. You can set sane defaults and things like that. There's quite a lot that you can do within these templates, within these JSON-based templates. But when you get down to the policy rule, this is where we hit pay dirt, right? This is what actually makes the policy effective, or not effective. But with a policy rule, it's a little bit tricky to define these rules. But basically, you have this if block, and within this if block, you can set values that you're not expecting, right? And so when you say the particular field should not be one of these, right? Then we can use in, right? So you can see here, the location should not be in this collection of allowed locations, right? So basically we're saying if our location on this resource is not in one of the allowed locations, the effect should be deny. That's it. Of course, you can use different effects in that then block, and you can use all kinds of different if conditions to check if values are this or if they're that. Of course, there's many different ways of checking equivalency, not equivalency, greater than, equal to, exists in a collection or not in a collection, those sorts of things. Definitely go check out the specification for this kind of JSON meta language to get an exhaustive list of all the things you can do in here. But just be clear, this can get a little crazy, right? Because these rules can get pretty complex depending on what you're trying to accomplish. So there's a lot of tools in your tool belt, when you set your match criteria. And that match criteria can get pretty big. There may be different conditionals and things like that you want to match on. The effects, there's quite a different number set of effects that do different things. And we're going to go in through a couple of different effects right now. Those effects, I think, fall into two main buckets. We have a bucket of immutable effects, right? Which basically there's no change applied onto what you're deploying at all. It's either approved or not approved. It doesn't change what you're sending in whatsoever. And so you can see here, audit is basically saying, hey, look for this. And if this is present, then that's a bad thing, right? And you're going to make it onto the naughty list. Audit, if does not exist, is kind of a converse, I suppose, where you're going to look for something that doesn't exist. And if it doesn't exist, you're going to mark them on the naughty list, right? Think like diagnostic settings, role assignments, things like that, that might be omitted in somebody's deployment, but you actually want those things to be there because they, are logging and they're adding security around certain things. And like missing NSG rules would be a great example of this. That's a very common use case where people apply those things. Audit if does not exist, it sounds complicated, but it is one of the more common checks to make. And then deny. What do you think deny does? Right? It says talk to the hand, like this is not happening. Don't let this go in under any circumstances. Now, when things get a little crazy is when you start doing mutable, right? Mutable effects, just like with immutable effects, like no changes are allowed. Mutable effects is when you want to instill some sort of change, right? And so with modify, right? Somebody sends you a deployment. You're going to change something about that deployment. Maybe they requested, 16 cores and 64 gigs of RAM, and you have a rule that has an effect that says if it's 16 cores and 64 gigs of RAM, change it to 8 cores and 32 gigs of RAM. I don't know, right? You can modify their deployment to let it go on through. Append, similar to that, you are maybe deploying a VM, right? And that's your deployment. You're going to append a virtual machine extension that maybe enables some telemetry or something like that. So you're adding something to their deployment before it goes through. And then delete, likewise, let's say somebody provisions a VM with a virtual machine extension, you want that thing off, you can just delete that. So that there's transformation happening through the Azure policy process. So this is, if you remember that diagram, Azure policy sits between the control plane and the resource providers. Basically, that's where that transformation takes place. So the deployment hits the control plane, hits ARM, and then the transformed version of that hits the resource provider, and then we come back. This can be problematic when your teams are working with infrastructure as code, because the whole point of infrastructure as code is that your infrastructure as code is defining what's going to be actually provisioned. So if you actually have policy come in there and transform what in your minds is the official, like what's going to, like the artifact that defines like what is in your environment, and you submit that to Azure, and then Azure policy sees that there's some policy definitions applied within the scope that you're deploying to with these mutable effects, and then it changes your deployment, then it's going to approve your request, but it's going to change what actually gets provisioned to your environment. And it's going to send back like everything was successful. This creates a little bit of confusion because from an infrastructure as code developer standpoint, my code was successfully deployed, but that's not actually what happened, right? There was some transformation that happened. And so the next time I run, do my deployment based on the exact same infrastructure as code, I'm gonna detect change. Like there is drift that occurred in that environment, and that drift was created by Azure policy doing these mutable effects, right? So there's an expectation on the part of the infrastructure as code developer that my deployment is going to be what my environment looks like, and the next time I go to deploy that, if I get thumbs up from Azure, there will be no changes, right? But that won't be the case if these mutable policies are applied. So it's something you should definitely watch out for when you have infrastructure as code developers within your organization, managing their environments in this way. With ClickOps, it doesn't matter, right? Like if I'm just clickety-clicking in the portal and I, submit, I say, yes, review and create, smash create. The fact that it gets transformed, I have no idea because I'm not maintaining an artifact. And that has the sole purpose of that artifact to represent the desired state configuration. I'm just like bouncing around in the portal, and like hoping things work out, right? So I think these, if you are in an organization where you have organizations that are working in a ClickOps model, then these mutable these policy effects are probably okay for you to use. But if you know that your organization, maybe you have a sophisticated level of infrastructure as code adoption across your organization, if you know that's the case, or if maybe there's pockets of your organization that have a sophisticated level of infrastructure as code, then you're probably going to want to define these policies in such a way that you're using immutable effects to just say, no, denied or audit, right? Deny, of course, would be a bit more disruptive, right? But usually in those environments where you have more sophisticated teams of infrastructure as code developers, then you probably already have an internal repository of infrastructure as code modules that those teams are using that conform to the policies that you've defined within your environment, right? So in that case, you already have paved the road. You've got these gold paved roads that your infrastructure as code developers are following, and it reduces the likelihood of them actually hitting a deny, right? It's important when you're defining policy to think through who the end user is and how this policy is going to affect their operating model. So very important stuff. Again, this is not an exhaustive list of all the effects that Azure Policy has. These are just a few examples of the two, worldviews, right? The two categories of immutable effects and mutable effects, because I thought it was really important to be aware that Azure Policy can do this, right? Just this is possible, right? But also what the cascading effects can be on your organization if you guys go a certain way with your policy, and your teams are operating in different capacities. So be aware of that. Azure Policy, in addition to sitting there on the in the control plane and creating its naughty and nice list, or talk to the hand, or doing these transformations, Azure Policy also has a dashboard, basically, at every level of Azure scope within the Azure topology. So any resource group, any subscription, heck, any even management group, any resource, there's a policy tab, and you can go look at this page. And this page will show you scoped, to whatever scope you're currently in within the context of the portal. It's going to filter down and zoom in for that particular scope, whether it's a resource, an individual resource, a resource group, a subscription. You'll only see the policy non-compliance or compliance within that particular context. So it's a very useful way for individual teams to see what's on their naughty list, what they need to go fix, what their technical debt looks like, but also for folks that sit across the organization that have a wider lens of the organization to kind of take an inventory of what all the technical debt there is across the organization. So it's a very flexible user interface that provides a lot of value here. And as you can see, a lot of that metadata shows up in this portal, right? So when you go look at the name and the description of these things, you can see kind of an idea of what's going on here. So here I have an AZ resiliency policy that's applied to my resource group. You can see the scope there. It's in my subscription / my resource group. And you can see that I have a number of different policy definitions assigned within this initiative. And you can see the ones that are compliant, and you can see the ones that are not compliant. And in this case, I just happen to have a Cosmos DB account that is not zone redundant. So this breaks this breaks the audit, right? It's auditing, this policy definition happens to be auditing for certain configurations within the Cosmos DB graph, within the schema of the Cosmos DB resource. It's looking for certain configured values. And if it doesn't get those values, it's going to say I'm non-compliant, because in this case, my Cosmos DB account has not been configured in a zone redundant way, right? So from the portal, I can go investigate this, go see like what the actual fields are it's looking for to determine like how do I go fix my Cosmos DB account so that I can move out of non-compliance and move into compliance. So this is not only good for just like, hey, what's broken, but also how do I fix it? Like what do I need to change? What values what do the values need to be on my resource in order to meet the requirements of this policy? And unfortunately, because each service is so different, it takes some investigation to figure out how much work that actually is. Some of the changes are going to be very easy, and some of the changes are not going to be super easy because they might be on attributes that will require that thing to be re-provisioned, right? And if you got to re-provision, then you got to start doing like a planning for blue-green deployment and things like that. So this, the Azure portal experience for Azure Policy is a truly helpful thing. But just bear in mind that not all policy definitions, not all attributes that break policy are equal, right? Some have a radically different level of time investment in order to fix them and get them right. So it's not a one-to-one. The reporting here does show 6 compliant, 1 non-compliant, and that makes me feel good, right? Oh, 86% compliant. However, if those 6 that are green, that are compliant, are very easy, low-hanging fruit ones, and that 1 non-compliant one takes, 800 man hours to go fix, right? I'm not saying that's the case here, but like just as an example, right? This percentage graph here doesn't necessarily reflect the effort. It is purely a quantitative view of, how many rules are broken and how many rules are good, right? So bear that in mind when you look within the scope of these resources. The converse is also true, or the inverse is also true. If I have, 37 out of 40 that are non-compliant, but they're all super easy to go fix, a big number, doesn't always translate to a lot of work either, right? And especially when you apply infrastructure as code, if I make one infrastructure as code change to a module that's been provisioned 100 times, like I can enact change very rapidly across my organization just by making fixes to those modules. But of course, I got to test those changes to make sure I don't break any of the systems or any of the teams that happen to be drawing a dependency on that module. So bear that in mind as well. Next, we have policy definitions, right? So we've looked at the anatomy of a policy. How do we make policies? But do we have to go hand roll our own policies from scratch? No. There are hundreds. There are dozens, if not hundreds, of policies that are already out there that are published that you can start using today. Many of these are already provisioned in the Azure portal, and you just need to reference them. More on that later. These built-in policies and built-in initiatives allow you to pretty much just find the ones that you like, that you want to use, look at their input parameters, figure out how to use them, and then assign them to your resources at whatever scope that you're trying to target. And so the different policies that are available, they cover the gamut, right? There's regulatory compliance, there's geography controls. Like let's say, our business is primarily in Europe. Like we don't need to be provisioning out in Asia or in North America or anything like that. So geography controls are some of those like baseline controls that enterprises set up from day one to just make sure, people, as a sanity check, to make sure we're not doing kind of nutty things that are unnecessary. But there's a ton of different useful policies out there that help you manage costs, right? That, of course, quota, I've heard quota can help with that as well. Sometimes as an organization, you want to set the quota, but you want to manage costs in a different way, right? And so cost optimization policies allow you to have finer grained control across your organization by applying it as policy, not just as quota within the particular subscriptions and things like that. Again, naming conventions, I think, is one of my favorites, all-time faves by far, because just there's so much, they're so easy and so simple to set up, but it just creates so much inefficiency if you have inconsistent naming conventions across your Azure landscape, because people are just like, oh, where's the key vault? Like, I have to sort this whole list to find a key vault. Like, just prefix it with KV and it's going to pop out to you much easier. So definitely employ naming conventions. But also there are some gotchas with naming conventions. You got to watch out, because sometimes Azure tries to be a little bit smarter than it is, and it'll provision things on your behalf that don't conform to these naming conventions, right? So like Network Watcher is a good example of that, or different resource groups that are spun up in order to to hold like Cloud Console and things like that. So just be aware of some of those things that are part of the wizard process in the portal that get auto provisioned when you do things in the portal, that they could conflict with these naming conventions. So you might want to think about that. And if those things that are auto provisioned in the absence of being provisioned, you might want to think about including those in your cloud landing zones to avoid those things to be auto provisioned anyway, right? Just as an aside. But of course, things like service usage and service configuration is probably the most important one. Like we were looking at earlier, zone resiliency for Cosmos DB, that's a service configuration one. It's like, do we want Cosmos DB to be configured in a certain way to be zonally resilient? Yes, let's make sure that our teams are doing that. You can also pair these up with different tags as well. So it's like, okay, if an environment is tagged as production, then we want everything to be zonally resilient and have private endpoints and things like that. If something is tagged as dev, then okay, maybe we can go a little lax on private endpoints and things like that. So you can mix and mash these together, by creating your own policy initiatives, by applying different policy assignments at different layers within your topology. It is a choose your own adventure. Absolutely, a tremendous resource of policies that you can use. So now, how do we actually codify these? Right. So we've looked at policy as code. We've talked about policy as code. We've talked about GitOps. We understand what Azure Policy is, right? We know that there's a whole bunch of these policy definitions that are already out there that we can start using today. And if we don't want to go write our own, then really what the policy as code that we're going to be doing is really just creating these policy assignments at the correct layers with our topology, and then configuring these policy definitions or these policy initiatives using the input variables. So how do we go do that? And it's relatively simple. Each of these built-in policies have a unique name. And using Terraform, you can reference that unique name using a data source. But in order to find the unique name, it can be a little bit tedious, because when you're in the portal, like there's ways to find it. I would recommend checking out the GitHub repo with all these policies defined in there. If you scroll all the way to the bottom of the policy definition or the policy initiative, you'll see the policy initiatives under policy set definitions, by the way. If you scroll all the way to the bottom, you'll see the name, and it's typically a GUID, which is not so human readable. So you might want to create a map or something so that you know what all these policy initiatives actually are in your Terraform code. But once you get that name, you can create a data source reference to that policy definition set. In this example, I'm just creating a reference to the AZ resiliency policy, which is in public preview, by the way, which has all those great rules to check and see if all of my Azure services have been configured to be zone redundant or zone resilient. And so usually, literally just by referencing this name, I now have a reference to that policy definition set. And now I just need to use a resource group policy assignment. Now, you'll pick up on the fact that the scope, the Azure topology, the level within the Azure topology is in the resource name here, right? So there are equivalent policy assignment resources for the management group, for the resource, for the subscription. And likewise, they have attributes that correspond to the scope that they're targeting. You can see here, I'm setting the resource group ID. If I were to use the Azure RM subscription policy assignment, then that leads me to believe that there will be a subscription ID that I need to set on that resource in order to assign it at that level within the Azure topology. And then, so that's basically it. You have a data source reference to the Azure policy initiatives, the built-in ones that are already out there that you just need the name to reference them. And then you create these policy assignments scoped to the target place within the Azure topology. You need to get the resource ID, the Azure resource ID path. Subscriptions have a pretty short one. Resource groups have a little bit longer one. Individual resources, which you probably won't use, have the longest ones. But you need to get that Azure resource ID and set that at the appropriate scoping attribute. In this case, the resource group ID. And then you need the policy definition ID, which is the ID off that data source up there for the policy set definition for AZ resiliency. Now, the last step, those components are what's connecting the dots between the scope, the Azure scope that I want to target this policy on, and the actual policy that I want to be applied. The next step is the parameters for that policy or that policy initiative. And so this is where you're going to have to go read the manual and figure out what the actual parameters are, like what the names of the parameters are, and what the allowed values are going to be. A good way to do that, of course, you can go out into the portal and you can go spelunking in the portal to find this stuff. But a wonderful reference is the actual Azure Policy GitHub repo that has the entire specification for every policy, built-in policy definition set or policy initiative out there. You can go look at all the parameters. You can see what the parameter names are. You can see what the defaults, what the sane defaults are and what the valid values are so that you can go configure these to your heart's content. So I definitely recommend to go out there, whatever policy or whatever policy initiative you plan on using, go take a really good look at what the parameters are and determine which ones you're okay with, the sane defaults, hopefully they're sane, and which ones you want to override, and then check the allowed values to make sure that you're plugging in the right values there. Now, here I'm using a Terraform technique called JSON encode. So I don't have, I think a lot of the examples out there on the internet just drop a blob of JSON here. But this, that's a little bit more difficult to maintain. So the technique that I'm using here is I'm using this JSON encode method to allow me to use Terraform syntax or HashiCorp configuration language to create a little bit more sane representation of the policy parameter definitions, right? So it makes it a little bit tighter, a little bit cleaner, a little bit easier to read. I'm just wrapping that into JSON encode because ultimately when Terraform provisions this role assignment, when Terraform provisions this policy assignment, it actually, spoiler alert, it actually needs the JSON blob to be sent up there, right? Which is why we have JSON encode there. So this approach allows me to balance readability, maintainability of the code with, what Azure actually needs, right? So I'd highly recommend this approach. If you do find a sample that has a big blob of JSON, dropped in there, just be aware that you can do this and it'll make your life so much easier. Lastly, how do we scale this to the enterprise? What does this look like when we apply policy as code using Terraform and Azure Policy? And so really this breaks down into a couple of different roles and that have different responsibilities. First, you're going to have enterprise governance that's probably going to be responsible for defining custom initiatives and policies. So if you want to do this, you don't have to do this, right? Because as we mentioned, there's tons of built-in policies that you can take advantage of right off the bat. But if those If those if those don't meet your needs, by all means, go write your own. You have the ability to do anything you want to trigger off of any Azure resources path parameter. Look for values that you like. Look for values that you don't like. Apply any effect that you so choose. Define your own policy definitions. Define those and group them into your own policy initiatives, and then publish them, to your Azure environment. And so you'll probably have a team that authors and maintains these custom policies and initiatives, and is responsible for that motion of updating them, documenting them, provisioning them to the Azure environment, and that they will likely have their own GitOps process around this set of Terraform code, because all this can be defined in Terraform, where you define these policy definitions. And then you can use Terraform like via CI/CD tool that triggers off of this Git repo where these are maintained to provision them out and maintain them out into the Azure landscape. Next, this is where you're probably going to assign Azure policy assignments to the appropriate locations within the Azure topology. And so this is going to be at the macro level, where you have management group level policy assignments that are going to have the broadest impact and hopefully the least amount of rules, because again, we want to make sure that we're not like totally borking everybody, right? But you're going to have policy assignments that are at that macro level view across management groups and various levels of the management group that affect entire departments within an enterprise. And then at a subscription level that might affect a team or a department, depending on how you've structured your team, or depending on how you've structured your subscriptions. This governance team will probably maintain those assignments, and they'll probably do that in a separate code base than the one that they actually define their policy set, the custom policies, because the built-in policies are already defined. They're already published out in Azure. And so we only need to publish our own custom initiatives and policies if we choose to do that. But then the assignments should be maintained separately, right? And this is going to allow us to, whatever policies we want to use, whether they be custom that we maintain in our own repos or built-in policies that Microsoft maintains and, publishes out to the Azure public cloud. We have another repo that is managing the assignments of either of those policy initiatives or policy definitions to the appropriate scopes. And you might even have more than one place where these policy assignments are maintained, right? Because depending on the size and scale of your enterprise, you might have multiple enterprise governance groups, right? One that might maintain management group level stuff or pockets of that management group hierarchy. And then you might also have governance groups that are much closer to the actual teams that maybe just manage policy assignments at the subscription level. And there may be a chain of command or something like that. So there's a lot of diversity in terms of how this enterprise governance team or groups of teams can be set up. So by no means do not think this is like a mandated structure, right? This can take on many, many different forms depending on how your organization is organized and set up. So definitely apply this concept to your organization, your entity. And then lastly, you might have actual development teams that are applying policies at the resource group level to do testing, or at the subscription level, to do their own self-service. Maybe they have their own naming conventions within their scoped pocket of the organization, and they like that. And the enterprise governance has got a little handshake, and they're like, yeah, okay, you do you. However you want to do naming conventions, that's fine. Whatever, go do you. But here is where you'll probably have policy or project level assignments for your policies, as well as where you might be incubating new policies and testing them before you broadcast them out to higher levels of the Azure landscape. So Azure policy and So codifying Azure policy via Terraform happens, in different ways, right? One is actually, defining the custom policies and the custom policy initiatives, which is very deep in that choose your own adventure. And then probably most folks are going to be operating with just the policy assignments. Like, let's take the built-in policies. There's a whole bunch of them. They probably meet our needs. We just need to figure out how to configure them and assign them to the right locations within our Azure landscape to make, to achieve whatever objectives that we want, whether it's managing cost, whether it's cleaning up naming conventions, whether it's employing AZ resiliency, whether it's employing sound security practices, across how our resources are provisioned, whatever the objectives are for your organization, it's up to you. You have the agency, you have the control, you have the choice of what policies that you want to apply and how you want to apply them and who applies them. But I hope you can see that leveraging policy as code through Terraform and organizing your teams and delineating the roles and responsibilities in this manner by applying a GitOps model to your policy as code, using Azure Policy, using Terraform, you can commit to control and reap the benefits of applying policy as code at scale within your organization. That's it from me. Happy Azure Spring Cleaning 2024. I hope you guys enjoyed my talk. Until next time, this is Mark Tinderholt, the Azure Terraformer, signing off.